Hello, team. Good evening, and welcome to the fifth day of our networking session. And on behalf of Eastern Academy, I welcome you all to this fifth day. And as usual, you can contact me anytime in WhatsApp if you have any issues. And even after that, not even completing, even after next week, you see the videos, you have a doubt, you can contact me. No problem. It's not only this week you can contact. No, that's not that. And we have extended one more day. Whoever could able to attend tomorrow, fine. Otherwise, I'll be sending the recorded version to others. I'm extremely sorry for that. And we are in the fifth day, and we are going to discuss about today what is a TCP address. And actually, they call TCP port instead of calling it address. So they're given a name called port. I'll tell you why it is. See, these are all the people have given a name for specific reasons. So one of them is a TCP port. We will just fastly walk through within 5 minutes what we discussed in the last 2 days. So we have discussed that how the data transfer happens. That is, we have system 1 and 2, and system 1 want the data, it's supposed to give it to system 2, but it goes through MAC. What it does is, it is adding the length, destination, source, and CRC, that's all. Then he makes it as information and given to physical layer. Then physical layer don't see anything. For him, it's once again ones and zeros. He does not bother. He doesn't know what is to address, from address. His job is to send it on the wire. That's all. Now, when he's sending it on the wire, he adds a preamble and SFD. That is about 7 and 1, 8 bits, 8 bytes. And then send it to the next file. Next file receives that. Once he receives, he checks, correct, man. The preamble, I could synchronize the clock. And after preamble, I got the start of free frame delimiter, SFD. So what the file does, he finds out that the things are fine. So now what happened? He starts removing that and sending whatever he receives, the remaining data, whatever this packet. He does not see what is inside. His job is not that. He has not been authorized to open and see what is inside. What he does is he give it to MAC. Once MAC receives the packet, system to MAC, he opens the packet and finds, oh God, good man, I got the address, it's my address. Then who sends it? Fine, he restore it. Then he sees the length. Then he checks everything is the CRC. Oh, the packet is fine. No, if there is nothing wrong with the packet, then what he does, the MAC does is, he removes all of them and send the information to system 2. This is the way the data, even though you have a single wire, so many things are happening on the background. Okay, this MAC and the PHY are generally below the hardware. They are actually chips. MAC is IC and PHY is IC. Okay, they are all components, physical components. Whereas what I told you, above the line, dotted line, they are all software. So whatever we are discussing, above this are all software. Only this is called the hardware. And these are generally called NIC card. Okay, that's all network industry uses a terminology called NIC. But today, it's not a separate card. We are just putting into the motherboard itself because of the VLSI technology, and the IC manufacturing has gone up. So we are doing that one. So this is the way the data could be anything. Data could be your video, data could be your audio, data could be your Word file, data could be your Excel file. It could be anything. It doesn't matter. You want to send it to other guy. That's it. Even the same thing is happening now. When I am talking here, you are listening by using the same methodology. Okay, you talk to the another IP and I talk to another IP. That's the way it's going. Now, see that we had so much of overload. The layer 1, that is a 5 layer. It has 7 bytes preamble and 1 byte. So 8 bytes overhead. Layer 2, which has destination, source address, length, and CRC. We are actually sending data only this much, but 18 bytes of overhead. So 18 plus 8 is 26 bytes. Okay. Then we have discussed about data transfer between globally. Previously, we discussed locally within my office. I have a group of people. I talk directly. That's all. We discussed about network. Now, inter-network. That's all. Inter-networking. That is called system one, trying to send the data to system two. Okay, it is globally somewhere. So that's why they have added called IP address. That is called inter-networking packet. That means that it is not in my network, it is beyond the place. So I added these two and I add a header. Forget about header. That's all software purpose. Okay, that we will discuss later if the time permits, or I will record and send it to you other videos. I'm not going to stop. I'm going to record few more videos. Every time I make a networking videos, I will send you all of them. I'll intimate you also. Okay, you can just watch them. And if you want to have any doubt, you can ask me. I'll create a video and send it to you. If you say that, hey, I have this doubt, and for example, I will create a video for CRC, how exactly the CRC is working. Okay, like that. Now, system one goes to IP. See that. Then what happened? The IP makes this as a data. All these things he took it. But this is what actual data. But for the IP, this is what data he made it. And he had given to the Mac. Mac is adding once again a MAC address. See that. So this packet contains now IP address as well as MAC address. Then MAC makes everything as a one thing. Oh, they are sent out by this guy, WhatsApp. I can send out the email also. If you want, I can send it. I can send out by email today. There's only one link. There's a directory. In the directory, you have everything. Okay. I can even start the directory at the end of the session. Okay. That directory can be used all the days. You don't have to do the whole everyday link. Okay. Every day at 10 o'clock, the video will be available. Okay. Now, see here, we have a system one and we have an IP, and IP finishes the packet. IP finishes the packet, then send it to Mac. Then Mac is adding the extra headers. Mac because he has to talk to the next machine. Then he give it to Phi. Now Phi is adding so many things. Phi added this preamble and the SFD. Then he give it to the Phi. Then it goes to Mac. Mac removes that and then give it to the IP. Then IP open the packet. See that. You need to understand the responsibility of each guy. This is exactly like a government office. In a government office, you go there. There'll be a clerk. The clerk give it to the officer. The officer give it to his superior. Then it goes to the director. Then it goes to the secretary. Then it goes to the minister. Okay, so it goes to so many people. And every guy is having their own responsibility. Okay, now same thing here. Because of the problem we normally call red tape. Because of that, if I have to send information or something to the minister, it has to go via so many people. It will take very long time. But here also same thing. But here the advantage is, because of this type of process, you can keep one person accountability. You know that who is the person who is responsible for not doing the activity. You can, let's say IP is not doing perfect, only change the IP process, put a better machine, put a better thing. That's the way. Now, then IP removes all the headers. See that? IP removes everything. Then he will give it to the system. Now let us assume that what is system one and system two. That's a very important. So this data itself so much. So now, if you look at that, this data reaches this guy, so many processes. And this is hardware. And as we mentioned, this IP, now above which the system one, system two have something called TCP that we are going to discuss today. See here, Once again, layer 3 have a 20 bytes overhead. So layer 3 is having 20 bytes overhead, and layer 1 is having 8 bytes overhead. Layer 2 is having 18 bytes overhead. Altogether, you have 46 bytes overhead itself now. If you want to send the 40 bytes, you have 46 bytes overhead. Now, even lot more is there that we're going to discuss now. Okay, so the next one is I have to go to the board because I'm going to discuss once again a concept. Wherever I'm trying to give you the concept, I'll move on to the board. When I'm trying to share some information, I'll be doing this. Correct. We took exactly 10 minutes to explain the last 2 days. Now we have another 50 minutes to do that. It's another very simple concept. Don't worry about it. This is a very simple concept. That is, I live in this is my road. Let us assume that this is my road. Okay. This could be, let's say, called as a Gandhi Road. Now here, I live in a house. My house number is 12. So you can say that number 12, Gandhi Road. Enough, no? The letter will come to my house. If you send any post, number 12, Gandhi Road, it will come to my house. But in my house, there could be 10 people. There could be 10 people. 1, 2, 3, 4, 5. Balaji, Ramesh, Ganesh, Vasha, Vyas, so many people. You have about, let's say that we have about 5 people in my house. So we normally say from outside world, it is a single house. Inside the house, so what happened when you write a letter, you'll say that Balaji, number 12, Gandhi Road. Am I right? We write the name and the address. Like that here. What happened? From outside, what you people see is a one computer. That is a PC with a monitor, with a keyboard, with a mouse. That's what you see, a computer. But within the computer, there are hundreds of computers. You know that? It's a very, very tricky. That's the way we are working. For example, let us take a case. In your laptop, you will have a window 1. There, you will be playing a song and hearing the headphone song. In another one, you will be typing a document. There will be one more window there, you will be having a mail. In another window, you will be downloading something. Understand? You will be doing multiple process, multiple activity in a single laptop. Am I right? But you have only one CPU. So what is happening is you have 4 activity, right? Let's say 4 activity. You have only one microprocessor or CPU, both are same. Original day CPU was different, microprocessor is different. Today, your microprocessor is a CPU. There's no difference. Both are same. CPU on a chip is called microprocessor. So what happened? This guy is playing a music. This guy is singing a notepad. And this guy is you do some design. This guy is a web browser. You are downloading something. You do so many activities, but there is only one microprocessor. What this guy does is, he is very fast. He is very, very fast. So he does some activity of this guy, then some, then go here, then come back, then come back. come back. So he'll be doing a round robin. He cannot do 4 activities at a time. He can do only 1 activity at a time. But since you have 4 of them, what he does is he doing a round robin. For example, for him, he will spend about 1 second, 1 second, 1 second, 1 second, then come back. So he is the one who is doing it on a round robin. So even though it looks to be only for outside world, you have 1 computer. You have 1 computer, but inside the computer, simultaneously, so many softwares are running. That is what you heard something called multitasking. But a task means process, duty, your work, whatever you call. Now, what is happening is, now you think of it. You think of a minute. Your computer, outside network, 1 computer, you'll be getting an IP of 192.168.10.1 because you have only 1 computer. But you may be having inside so many applications. 1 application, okay, could be downloading from Microsoft. 1 application, you'll be uploading a file to the Google Drive. In another application, you'll be downloading you'll be hearing a music. Now you see, there's another application, you'll be doing playing something. Okay, so you are doing 4 activities, or you may be chatting with your friend. See that? But the problem is, all the 4 friends are at 4 different places. One could be at Bangalore. One could be at New York. One could be at Australia. One could be at Delhi. See that? So now you from Chennai can talk to anybody simultaneously. That is the trick. Simultaneously, it is possible because even though you have only 1 laptop, it has only 1 CPU. It is made simultaneously possible because of its speed. Let us say I am the person, I can do 100 activities per second. I'm so fast. I'm a Superman. I can do 100 activities per second. I have 4 managers, 4 boss. I have a 4 boss. I am a Balaji. I have 4 boss. Boss 1, boss 2, boss 3, and boss 4. Each one, I can do 100 activities per second. I'm very fast. This boss is giving you activity 1. He is giving 1. He is but everybody is expecting I have to finish the thing in 10 seconds. See that? Everybody is expecting how many seconds? 10 seconds. Okay. Sorry, 1 second. Sorry. Everybody wanted to finish the thing in 1 second. But I can do how many activities? 100 activities per second. So what I do is I take this first boss activity, finish it in 1/100th of a second. And I do second activity, another 1/100. So even though I can do 4, they are given only 4 activity, I'm going to ideal for remaining 96% of time. I will use only 4%. That's what normally you go and see. What is the CPU utilization in your PC? Okay, that's why they tell you that how much CPU is utilized. Okay, normally if you see it be very low, unless you run a very important computing job. Normally CPU will be running very low. Okay, now same thing. Now the beauty is Microsoft computer somewhere in Bangalore, and I'm uploading Google Drive maybe in New York, and I'm playing a music from Australia computer. I am chatting with somebody in Delhi. Now those people, everybody is having a what? IP address. IP1, IP2. See, the moment you connect to the network, you have been given IP. The moment you without IP is waste. Okay. Now please don't bring out Mac at all. Mac is not coming to the picture at all now. Mac job is over now. I will explain to you later tomorrow exactly how the Mac is used. That if you understand how the Mac is used, you know that Mac can be easily forgotten. Okay. Now the trick here is the most important thing for us is IP, because it allows us to connect any computer in the world. Even I have a computer, somebody could be sitting next to me, but we connect to only IP. We don't because the software are standardized with TCP/IP. So even though next to me, my group, I don't use only Mac. I use even IP. I consider them. I am Balaji Chennai and you are Ganesh Chennai. I don't see use a local address. Okay, local address is used for some specific purpose. That's all. Everything is global. Now what I'm trying to convey is very clear. The moment you connect to the network, see, the moment we say means if you send it here, it will go to anybody. Okay, let us assume that my IP is 192.168.10.5 and Microsoft IP at Bangalore is 10.15.25.35. Now, if you make a packet to IP from IP and my information, my song or whatever it is, now when I give it to him here, you don't have to worry. It'll go to him. That is what guaranteed by the IP. The IP guarantees your packet is delivered to the other end successfully, other computer, not to the other guys. Now, the very unfortunate thing is, even that computer itself could be doing so many activities. Somebody from somewhere could connect to the other application of the Microsoft. Am I right? Not to the same thing. So, like your computer is having 4 process, 1, 2, 3, 4. Even the other Microsoft computer in the Bangalore, they may be having 4 process, 1, 2, 3, 4. The computer in New York could be having 4 process. So, for example, you are trying to connect from the process 1 of your computer to process 4 of Microsoft computer. Okay, this address, you can call it as a sub IP or whatever it is. This address is called what? This 123 within your computer is called TCP address or TCP port. Okay, like that, they thought in a computer you can run up to 65,536 applications you can run. And the beauty is your computer itself can talk one process to other computer, other process. So how do I exactly say that? It's like this. I have a single path, but here a computer, here a computer. Forget about the network and all. This is single path. Now my system have so many process. Each one can talk to each one. Now I list out all of them. Now there are about 3 addresses. One is your application will have address. Okay, this is what exactly they call it as a different name. I'll tell you what is the name of it. What happened? I am Balaji. I open a browser. My computer is nothing now. There's no application on my computer. In my computer, there's no application. I just on the machine, there is no application. Now I open the browser. Okay. Now the browser is idle. It is not doing anything. The moment I give www.google.com, Am I right? I'm connecting to google.com. Now this guy gets the equivalent IP address. Could be 10.11.25.35. I told you there's a table called DNS. I'll tell you how we are accessing the DNS. How do you the whole process I'll explain to you. Then if it's not a single one, I won't tell you the whole process. How when you do the browser to how do you get the everything? Now, once you get it, IP address, then your browser, okay, this is an application. You will be taking a port, okay. Then let's say that you have a port address is 80. So it is called 10.11.25.35 is your machine address. This is your machine address. This is his machine address. That is Google address. Then there you're going to talk to his address is 80. That is what the application in the Google you want to talk on a Google machine. Now, what is happening is you may be having IP address. Your IP address is 192.168.10.20. So 192.168.10.20. And you have a TCP because I told you your computer can run multiple applications. Now, one of the applications is Google. So let us say my thing is 8,000, whatever it is. You take some number or 100. Now, what is happening is in the world, there are two computers somewhere. See that? In the world, there are two computers anywhere. That is, one is so many computers are there in between. And you from Chennai office, connect to your ISP BSNL. And BSNL could be connected to another guy. Then the other guy could be connecting here. This should go to New York. In between, it goes via so many people because you know that there are cables are running under the sea. Am I right? Or it go to satellite, whatever it is. So all the fiber cables from here, from Chennai to Singapore, from Singapore to US, and US to New York, you can go. Am I right? These cables are all going under the sea. Okay. You know that there is a big companies in India like Tata. They are only maintaining all the things. They are the world's biggest under the sea cable layer and maintaining the things. All of them are under the ocean bed. They are lying that. Okay. Otherwise, it will not be very fast. You download a file from Microsoft from US, it will not be as fast. There are other reasons we'll discuss later. They're all mirroring and everything. Now, and the New York, there is a computer. In that computer, there is a process. I am talking in my computer, Chennai computer. I have a browser in my computer. I have an IP here, 192.168.10.1. Understand? The moment I connect to the network, I need to have an IP. And this guy is having IP, 10.11.12.15. Done now. Now two IPs are done. Now what is happening is, I have connected a Chennai office. I connected my process, my browser window. I have a Chrome. The Chrome, I opened a site called Google. Am I right? That is what this. Now, this I get see, don't confuse with the IP address and this address because my computer can have so many other processes. This address is, let's say, 100. And I'm talking to this guy as 80. Okay. I'm talking from 100 and I'm talking to 80. Till I close the window. I am the one who started okay, who started the browser. I only typed google.com. Till I close the window, Google, the connection will be there. The moment I remove it, then the system will close my application. then there could be another application for this 100 will be allotted. So the numbers are all allotted dynamically. Now you see here, I have a application where I have a number. This number 192, 168, 10.1 plus 100. This is IP. This is TCP. I'll give you a name called what is TCP and all. Those things are very important, not very important. The most important thing is how they are talking to other guy. Okay. Now that guy is talking to 10.11.72.15 with 80. This connection looks to be permanent till you close the window. The guy who is giving the information to you is called server, like a hotel that opens all the time. Like yeah, that I'll tell you exactly. That's a very good question. How the PC knows that one process address in another, these are all fixed. They will say that every application, if you don't know the address, then you cannot know. But we know that web browsing means 80. It's a fixed address. If it's a FTP means there's an address. If it's a what do you call telnet, for every application, see, I told you, there are 65,536, out of which up to 1024 address are fixed for each application. Like 80 means web application is having a port 80. Am I right? If you want to talk to them with 80, but if you have your own application, let us say that you want to talk to your computer from Chennai, which is some address 1783, and you want to talk to the other computer with 7591, then you should know that. If you don't know the address, how come you should know his IP address? See, don't get confused with when I say IP address, that is whether when I say IP address or google.com, both are same. If you don't know where you want to go in the browser, if you don't type the name, you cannot go. That is IP address. Okay. Same way, if you do not know the application number, the TCP address, you cannot go there. Otherwise, that should be standard. In your browser, if you say google.com, the browser knows that. The browser by default, worldwide standard, they know that browser go to the web server, that address is 80. This fixed. It is fixed. This was standard call. Up to 1024, there is a standard addresses. Okay, those things I can send it to you a document by mail. I can send you by document by mail that what are the 1000. This is all available in the web. You go and search it. Whatever you can get it on web, I don't do that. I can also provide you the data. DNS survey is maintained by so many people. Google maintains DNS server. Actually, every DNS server is having address. For example, 8.8.8.8. That guy is maintaining the DNS server. Microsoft maintaining DNS server. So many people are maintaining DNS servers. Okay. Initially, it was only the Internet Committee has maintained. Then a lot of people start maintaining the server. Okay. That way they get the information, how the traffic is going, who is asking and everything. So they want all the information. That's fine. Now, this one is the industry has given a typical word. What happened? What I do here is when I develop a software, see that the server is the one which always running. Like a hotel. Hotel is a one. You cannot run. Then you have to give a different IP. The other person should access with a different. There'll be only one standard address with you. If you want to run one more server, that should be given a different address. You can do that, but with the 80 there is only one. which is a standard. HTTP servers address is TCP address is TCP port is 80. If you have to run one more, you have to run 81. You can run two. You can run any process. But the problem is when somebody wanted to communicate to you with 80, they can connect. But I can say that google.com colon 81. Then I'll come to you. It is possible. You can say that address here in the browser itself. Then it will go to the specific port, not to your port. Otherwise, by default, it will go to 80. 80 is a standard. That's a trick. You can run any. So let's take one server now. Server is like a hotel. It is ready for 24 hours serving you. If I say that if Microsoft say I have a server which runs 24 hours, that means that you as a customer can establish a connection with him and take the data. How do you establish a connection? You will tell him Microsoft IP address plus the port address 80. That is his browser. You are trying to talk to, let's assume, that web. Then your computer address. My computer address is 192.168.75.1. Then my port address is, let's say, that 70, assume. This, till I close my browser, this connection will be there. So this one, 192.168.75.1 at 70 to Microsoft IP with 80. This whole thing is called, they've given a unique name. This is called socket. This is called socket. That means that you plug the socket at both the end. When both the sockets are connected, you can communicate. If one of you pull down, let us assume that the moment you close your window, that particular browser window, then the connection will be lost. But let us assume that afterwards, you may open one more application here. That application also could have got 70. Then that will establish a socket. So the port number for you is not fixed. It could be anything as you wish. So that is what they call it as a. So I will explain the whole flow tomorrow, but because that has to be explained with how the switch works, how the router works. Okay, which with them, what is gateway? What is gateway? What is NAT? With all of them, these are all the terminologies we use in networking. With that, I have to explain, then only you will understand. Now, I'm trying to explain the bits and pieces. I want to make sure that what is the purpose of IP? What is the purpose of MAC? Communicate the next machine. His job is over. Now we are not discussing with him. We will discuss with him tomorrow. That's all. Till that time, I not worry. He will make sure that the data goes to the next machine. That's all. Otherwise, you cannot communicate at all. With IP, I cannot talk to the next machine. IP is used for global communication. But to talk to my close friend in my group, I have to use only MAC. Without MAC, no communication. Next one is called, we discuss about IP address. IP is the one we use for any computer anywhere in the world. It doesn't matter. We put like this network. How it goes from Chennai to New York, that's fine. That you don't have to worry about that. Okay, that you don't have to worry. That's a path we'll discuss tomorrow. How the network is safely taking your job to the thing. But now we should know what the IP does is, the moment you given a packet, IP makes sure that it reaches that. But there are so many things to happen. The problem is, let us say that the packet from here, it goes there. if it takes more time, okay, somebody in between say that, oh, this packet is taking long time, man, they will drop the packet. It will not reach at all. From your Chennai mission to New York, you could have sent the IP packet. It would have been lost. The packet is gone. Same way, there is a, in between two missions, there could be a cable problem. Then you could have lost the packet here. You could lose the packet. Any reason. Okay? Because your checksum is wrong. The packet is lost. Now there could be huge congestion in between somewhere. You could lose the packet. Now, if you lose the packet, how do you find out? For that only, we have understand one important thing. First MAC, I send it to next by. If something happen, if my CRC is wrong, if a CRC is wrong, this guy will not tell him, A will not tell it to B that I did not receive. That guy will just drop the packet. He keep quiet. He will not bother. The B will not bother to tell A in the Ethernet, I have not received, no acknowledgement at all. So the packet is dropped. Okay, so nobody bothers why the packet is gone. Now what happened? The MAC get the packets from IP, and this guy give it to the other IP. IP2, MAC2. MAC1, IP1. IP1 give it to MAC1. MAC1 give it to MAC2. MAC2 give it to IP2. Now, in the process, it could be because of MAC, it could be because of IP, this is because of the IP. The packet is lost. Nobody knows. But this guy, TCP, he comes to the picture. When he gives the packet here, when this guy receives the packet, this guy wait for an acknowledgement. If you don't get the acknowledgement, then he will say that he has to retransmit the packet. Who will now understand one thing? MAC does not have a responsibility. IP does not have a responsibility. Who has a responsibility? TCP. That's why they call TCP as a connection-oriented protocol. That means that it will take care of all the acknowledgement, everything. There is something called, like TCP, they have something called UDP. That guy is like IP. He never, let's say you are hearing a song from where. It doesn't matter, man. If one frame goes off, gone. You don't worry. You don't play it back later. Let's say that you are hearing you are watching a movie. Packet is coming. One frame is lost. That doesn't mean that I have to get it back and play it back. That's gone. The gone is gone. That millisecond of video is gone. That we'll discuss later. I'm not because I don't want to have too many terminologies. Let us take only a very, very unique terminology teaching. I'm trying to explain what is the use of layer 4. Layer 4 is the one which makes sure that anything happens in between. He makes sure that the other guy, TCP1, TCP2, receives the packet successfully. How he does? For that, there is a trick. Let us assume that I am at Chennai. That guy is at New York. I transmit a packet. I go to BSNL. BSNL go to some Singapore thing, and that guy gave it to somebody in Boston. From that, it goes to New York. Think of it. So the packet takes so much of time. Then he will get the packet to me. This is called turnaround time. Turnaround time. Because of this time going and coming back to me, the problem is, let us take the whole time is 1 millisecond. For example, you take a very small time. So I will send one packet. Then I wait for the acknowledgement. Then I send another packet. So this time is waste time. This time is waste time. So to avoid that, the engineers found or mathematicians, actually this was proposed by mathematicians, they found a nice method. What they have done is they said that, Baba, do one thing. You don't worry. I'll be sending the packet. You keep on sending the packet. I keep on giving acknowledgement. But if you want to send 10 packets, send all the 10, one by one. Don't wait for the acknowledgement. That's what happened. If you don't wait for the acknowledgement, what is the use of acknowledgement? For that, they have a concept called window. What is the window means? Correct. That's correct. When we see the full path, we'll understand it. Now I'm trying to explain one of the simple thing of TCP have a multiple reasons. One is TCP is having a number for specific application. Other one is TCP ensures that the data reaches the other side successfully. To take the data, it is waiting for acknowledgement. But I send the data and wait for acknowledgement. Let's say I have 10 packets. Okay, now 10 packets. If I have to send one and wait for the acknowledgement, then send 2, then 3, then 4. I'm wasting a lot of time. So what they are telling is, don't wait. Don't wait. Instead of that, you send 1, 2, 3, 4 continuously. But make sure that you have only 4 packets without acknowledgement. You will be having 10 packets. How many packets? You have 10 packets, 1 to 10. But you can send 1, 2, 3, 4. Now, how many packets are wait? 4 packets. Then you are not supposed to send the 5th packet. You have been allowed to send only how many packets? 4 packets without acknowledgement. Now what happened? That guy is sending acknowledgement. Okay. When he sent 1, he received 1. When he sent 2, he received 2. Then he will say, oh, 1. Suppose, let us assume that you are sending a packet 1, 2. But before sending 3, you got acknowledgement for 1. Then you will remove it because you got the acknowledgement for the 2nd packet. Then you will send a 3rd packet. You are sending a 4th packet. That time you got acknowledgement for 2nd packet. Then you will do. Now you have how many packets waiting? Then you will send 5. Okay, you send 6. Before sending 7, you got 3. So this can remove. Now only 3 packets. You can send 7. Now what happened? If he says suddenly 5, it means that he indirectly telling you that I received 4 and 5. That is the rule of the game. He need not, sometime he need not have to tell you that 1, 2, 3, 4. If he says that after 1, if he receives 2, 3, if he sends a number 3, it tells you that I got 1, 2, 3 by chance. If you get 1 and 3, if you did not get 2, then he will send you acknowledgement I did not get 2. Then you have to start transmitting once again from 2, 3. So this is a way the TCP layer works. That's why they call it as a transport. These acknowledgement connections are there in TCP, whereas that is not there in UDP. UDP is like a telegram, not a registered post, a telegram. You will not get acknowledgement. You send the packet, it will go there. That's all. But whereas TCP, all the important transactions are running by TCP. Yeah, no, not sliding window protocol. Like this is called sliding window protocol. I didn't use the word terminology sliding window. What is a sliding window is I have a digit, I have 4 packets now, 1, 2, 3, 4. I keep it here. Oh, I send one packet. I'm waiting for one packet acknowledgement. Then second packet sent. I got this fine. Then I'll go to 2, 3, 4. So the sequence number, this is called, they call this as a sequence number. So I keep on sending the packets with the sequence number. So if I don't get the acknowledgement from the other guy, then there's a timeout. Okay, then I have to retransmit. That's a this whole thing is done by your TCP protocol. So TCP, I will recollect once again this back. Give me a time because I don't want it to have pushing too much. What I'm trying to tell you is that this guy is good for acknowledgement, whereas your other two people, MAC and IP, they are not responsible for data transmission successfully. They do not wait for acknowledgement. They just transmit. If something happens somewhere, they drop the packet, they will not give you acknowledgement. Whereas in TCP, every packet you send, you will be getting acknowledgement. That's the only difference between these three people. That's why they make sure that these three people, IP, TCP, and MAC, physical. These are all the very important. So your actual application runs here. Application is safe. You are copying a file. I'll tell you one thing. Let us say that you have a MP3 song. You have a MP3 song, which is about 10K size. How much is 10K size? You know that the packet at the bottom, your Mac, cannot take more than 1500 bytes. But this is how much? 10,000 bytes. You have 10,000 bytes are there, but you cannot transmit more than 1500 bytes. Yeah, TCP is a protocol. Yeah, it's all protocol. TCP, IP, all of them are protocols because they have a rules. How the other guy have to be there, how I have to behave, how I have to transmit. I have a format. How should I do that? They're all protocol. Okay. For the protocol, they said there is a format, header format. This data, the header, successfully helps you to establish the protocol. Otherwise, you cannot make the protocol work. For that, you need some data. So see that I have a file which has 10,000 bytes. What the TCP does, it will split into 10 packets of 1,000, 1,000, 1,000, 1,000. Who does this? So a file, you are giving me a data of 10,000 bytes. I will split into 10 segments. This thing use the word called segment. TCP will split into segment. Then after it segment the packet, it will take only one, give it to IP. Then IP will add the headers. Like TCP also will add the header. I told you the sequence number, the port number, all of them are added by the TCP. Then IP will add the IP address and the other informations. Right now, don't get into the too much of information will kill you. This is understand the top level bird view. Don't get into the every packet details. Then you're gone. If you get into that, you don't understand this. That's the reason. Now, what the IP does is he give it to MAC. This one, this data, TCP data, plus the IP header, this is called packet. Now, this guy, the TCP gives this, IP gives the data. This guy is called MAC to MAC from MAC. Okay, These are added. This is called frame. So there are three terminology: frame, packet, and segment. Then when you give it to the bottom, our man, physical layer, add to the preamble and SFD. This is called bits. Because this guy does not know anything. He does not understand anything. For him, everything is ones and zeros. That's why we call them bit. So there are these four are the very, very essential thing. These four are the very essential thing of network. Very unfortunately, now you know that, there are four. One is phi. That guy responsibility, the phi responsibility is to send the data there. If there's a 1 means 1, 0 means 0. He does so many methods, whatever method. He could send to wire or wireless or fiber, phi responsibility, and also send the preamble to do the clock synchronization and send the SFD to make sure that, okay. So the phi does as much as possible. See, you clearly understand the word as much as possible. Okay, not 100%, as much as possible. The as much as possible could be 50% or 99.999%, whatever it is. That guy, make sure that whatever bits you are given, he will send it there sequentially. That's all. His job is over. Then the MAC guy, make sure that the packet receives the next guy. The third person is a very important. That guy is having IP address, inter-networking packet. That's called from one network to other network. He makes sure that the packet, the IP address is correct. It come to me. My IP address has come. Now, the final one is called TCP port. The problem, the TCP port is, that guy, you send a packet to all the people. Then that guy will acknowledgement. Now the problem is, if any of the guy, here is a problem, or 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 here is a problem, anybody, anything could be faulty. Anything could be faulty. Even, see, he could have received the packet successfully, but we said the acknowledgement could be faulty. See, the problem for, I don't mind. The person A does not bother anything. For me, I have to get the packet, man. I given the IP. It is IP responsible to send it to the other IP. And MAC responsible to send the other MAC. The phi responsible to send the other MAC. Everybody is having their own responsibility. Now, the TCP is the one who makes sure that my packet is successfully transmitted other end. If it is not sent to other end, the TCP does three jobs. One is, it has a port number. Because of that, I can have a multiple connections. That means that I can have a multiple applications talking to multiple applications there. For example, simultaneously, my computer with a TCP IP. Forget about the whole thing. This is all my one computer, one screen. One screen, one application could talk to the Intel, one application. Other application could talk to the Microsoft, one application. So I am talking to various people. How could it possible? Am I right? That is makes it possible by TCP. See, IP connect your computer to other computer, but TCP makes in your computer itself one other application to other computers one other application. See the combination. That means that you can have 65,536 application. That's what they thought that's sufficient, but maybe tomorrow even that itself will be maybe because of CPU power, you can run more application. Right now we are running only that. So these are the elements of network, basic elements which connect. Now, one thing is not clear to everybody. How these things are exactly used. Everybody is, now we know that everybody's responsibilities are very clear. Okay, this guy is having a data. He gets data. I get, let's say D1. D1. I add a header. Then it becomes D2. D2 and a header. Then I get D3. I add a header and a footer. Then I add D4. Then I add header. That's what your preamble and SFD. Now, everybody is adding so many piece of information. But the beauty is when it goes here, this guy will slip off this. Then only this goes to this guy. And this guy goes. So each and every guy, they do their job. But in between, there were lots of informations are missing in the whole network. That job we are going to discuss tomorrow. That is the one job done by your switch, hub, repeater, and router. You can call gateway also here. Gateway, router, and NAT. These are the ones. If you understand them, you understand how exactly the packet is traveled from your computer to everywhere. Yeah, I'll once I complete my given task, I'll today we don't mind. Today we can even extend 1 hour off the record discussion. 1 hour I complete the whole process of how the packets are going from your computer to the other computer. Okay, so please make sure that you try to understand what we discussed up to today. Okay, what is the responsibility of each one of them? Okay, we will discuss about the other one by tomorrow. We will discuss about, once we discuss how the packet reaches the other ones, then I will discuss about the session layer, presentation layer, application layer. But today we call everything as a one application. These two, TCP and IP, they are called stack. And MAC and PHY, we are called hardware or NIC card. So right now, even though OSA layer, 7 of them are there, these 2 is one portion, these 2 another portion, these 3 another portion. Today we do not segregate between session and presentation and application. They thought about it, but today we don't do that. Today everything is called single application. I will tomorrow tell you that how do you open the socket, you can build your own server. You can develop a small application, you can build your own server. Okay, you need not be a client, you can be a server. Okay, this topic is quite easy, man. Now you understand these basics. You do not have to work on this. You can directly start working on the software. Then things will be very clear. You know that how the packets are traveling, where exactly is going. No, now it may not be very clear. I know that. Now it is not. Now we discussed the individual components, but we did not connect all of them. That connectivity of all the portions, which we are going to do tomorrow, then we will know. That's why I told you that tomorrow, how we are going to use these things to make the connectivity. What is each one plays a role. Sometimes they say switch, sometimes they say router, somebody called gateway, everything. Somebody called NAT. What everyone is doing the role. Then this 4 layers, TCP, IP, MAC, and PHY, and this 6 of the devices, things will be very clear. But till that time, you just think about it, search in the Google, whatever information you get it, watch this video, whatever information you want it, you get it. Okay, what's the time now? Okay, it's 8:05. Let me close the recording, and we can able to discuss afterwards any doubts.